Hello everyone, this is lecture 3 and in this lecture we're going to talk about methods and arrays in Java. We talk about conceptual issues about methods and arrays and along with that I'll show you how to solve certain problems using these simple concepts in programming and I'll demonstrate you a couple of examples using Java. So we'll talk about important topics that are related to methods. For example, we'll discuss about static methods. It's fields that are associated normally with classes rather than objects. We'll talk about how the method calls are resolved using Java with the help of a method call stack. We'll discuss about how arguments can get converted into a higher level of the data types. And at the end, we'll talk about one particular case study where we implement a game of chance using the concepts that we discussed above. We'll also talk about arrays, how we can go and iterate through, initialize arrays, declare arrays, or iterate through the elements of the arrays. And also talk about how arrays can be passed into functions, into methods, and how can we go and pack the arrays from the arguments using the variable length argument lists and so forth. So at the end also we'll discuss about a type of a collection called an array list, which can be dynamically resized unlike many other array types. So these concepts could be very familiar to you from the previous programming classes, but I do urge you to walk through the lecture in order to have a complete understanding of how these concepts are implemented and used in Java. So, so why do we need methods in general? So the methods are one way of dealing with the problem in a divide and conquer fashion. So we can break the problem into smaller problems, and then those problems can be broken down into smaller problems, into reusable problems, solutions to those problems. And those solutions can be used over and over again, and their small solutions can be combined into something greater. So we can basically build some sort of a hierarchy of methods, and this hierarchy of methods can actually help us to deal with a particular big problem in a divide and conquer fashion, right? So, and I'm going to show you some examples on doing this kind of idea. But along with doing things, as I said, we'll talk about static methods and then method call stack. So divide and conquer method is not necessarily applied to functional decomposition. It can be applied to building classes as well. So basically, when we are dealing with a problem in terms of classes and methods, we are basically looking into the world in the form of entities and the way how they interact with each other with self-contained units. And the methods are the ones that basically describe the behavior of these entities in the real world and the way how these entities interact in the real world. So so the idea here is that the statements in the method bodies are basically written once, and they hide the implementation of that particular logic from the outside use. And the most important thing about the method is that it can be used multiple times in different locations by a caller of the method, right? So so this way we can again create this small reusable units like methods, and this reusability is the main aspect, main concept why programming languages like Java or any other languages like procedure-oriented languages have methods in mind. But we're going to look into how they are defined and processed. So in order to make sure that our methods are well defined, we should provide them some sort of a meaningful name to the method. And so the name of the method should be, you should be able to easily describe this particular method. If a particular method performs too many tasks, then perhaps your method is doing a lot of things, and you have to break it down further into smaller methods, and then and that in that method call these smaller methods. So So if you're kind of hesitating to find a good name for your method, then it's kind of a red flag for you. So you say, okay, I don't know how to name this particular method because it's doing so many things. So it would be easier for you if you go and break down its content into other smaller methods, and in those smaller methods you should be able to describe the job that particular method is doing. So also make sure that one method has to do only one task. You cannot make a method which does multiple different tasks. Like so, on the lowest level, of course, right? So try to break your methods into smaller tasks. The single task that particular method does, even if it's just a one-line task, it has to be a single task, not many tasks. And this is a good practice of programming. So there is a hierarchical relationship between the method calls, especially in your program, and you should understand how this hierarchical relationship actually works. So there is always the caller, or let's call it a boss method, okay, a caller method, and the one which is called the worker or the called method, right? So there will be some method calling another method in your application, and once the worker method finishes its job, it basically reports back to the boss saying, I finished the job and this is what you were asking from me. So this is, and you can see this kind of hierarchical relationship, and especially you're writing in any application so far, we have a class, application class, and inside this application has a main function, right? In this main function, we are calling other methods. So our main function is sort of a boss that calls other methods, which are workers, and they are doing their job to report to the boss, right? So, so the good thing about this hierarchical relationship is that the boss has doesn't have to look into the intricacies, inner workings of the implementation of the workers, things that the workers are doing. So workers are somehow hiding the implementation details, and they're basically doing their job and returning back the values that are expected by that particular boss method. And a good thing about doing this kind of hierarchical relationship is also improves the readability of your code. If you look into the, let's say, content of the boss method, the caller method, right, you should be able to read it as if it's sort of a documentation. So you don't have to go and write a separate documentation for that particular method, right? So if you just look into the code, it should be easily understood by any programmer. So again, the choice of method names is very important in this particular scenario, because you're looking into this bot and you're seeing what kind of operations, high-level operations, are being executed, and then you have some sort of the idea of the whole algorithm that this particular boss is trying to execute. So look into this particular hierarchy here, right? So you might consider this boss as the main function of your application, and let's say, okay, this main function of your application is let's say it's the application which does the airline system. And this airline system has a lot of different things it needs to do to interact with the user, right? So it has to print out, let's say, a greeting message saying, okay, welcome to the airline system, something like that, right, in the console. So, and printing out a greeting message is one task, and now boss can go and delegate that particular task to a different method, and this time it could be a particular function saying print greeting message. Also, this particular airline system should be able to show the menu, right? It has to say what kind of operations the user can complete with this particular system. So it has to display some sort of a menu where the user can choose the operation and then carry out. So the printing the menu part is another task, and it has to be accomplished by a different worker. And this worker is now hiding the implementation details of the menu. But all the boss needs to know is that, okay, there is a worker. This worker is responsible for printing the menu. So it can go and ask the worker to print out the menu, this menu, and it prints out the menu. And another important task for the airline system could be just assigning the seats to the passenger, to a potential passenger. And this method could be a little bit more complex than just going and assigning something. It might also rely on other methods, right? So this assigning a seat to a passenger might rely on another method which goes and checks, okay, if there is a seat available in the airplane or not, and if and this method basically does all the low-level implementation of going and checking that, right? So maybe it can go and connect to the database and find out if there is any seat remaining for that particular passenger, okay? And this method could basically do the assignment, right? So it gets, let's say if there is a seat in this airplane, this one is the one which goes and updates or occupies a given seat, okay, in this airplane. So so these two functions, they could be kind of they're doing the same job, and the job is assigning a seat to a passenger. So but this one is basically the whole application and has other things to do as well, like printing some messages to the user. So all of these things all together make up a one big single application, and you can see this sort of hierarchical relationship in the functional decomposition of this application. So every time looking into this application, again from the perspective of a boss, try to decompose the task into smaller tasks, into manageable tasks, right? And then just try to keep on breaking down the tasks into smaller and smaller ones until there is a one single task that particular worker does, and there is no other thing that particular worker is responsible to. So if the worker is kind of responsible to one particular task, doesn't take any external input in the sense that it's just does a one single operation, then you know that, okay, I just reached the bottom and I don't need to go and further break it down into smaller units, right? So and also another important thing in this case is that, let's say this worker is responsible for, let's say, assigning the seat, right? And inside this worker, it is using these functions, this level of functions. But this worker, if this worker goes and uses this particular function, then this will be the violation of the abstract levels, right? So the violation of its levels. Why? Because it kind of breaks the hierarchy in the sense that this worker is now going and talking to its peer. So of course, in some cases, you might have this kind of calls between the peer level functions, okay, and because this could be the inevitable case, but you have to understand that this is a bad design choice. Your worker always need to go and talk to the lower level workers, okay? So and it cannot go and invoke some other worker which is maybe at the same level or a higher level or something like that. So whenever you're writing a code inside this worker one, okay, make sure that you write code with the workers of a one level below, not two level below or not three level below. Also, if boss tries to go and call worker 4, it also be the violation of this hierarchical relationship, right? So boss cannot go and directly call the worker 4. Instead, it has to go and call the worker 1, and the worker 1 has to go and call the worker 4. So when you're designing an application, okay, when you're doing this kind of functional decomposition of your application, writing a program, just try to think in that particular respect. So the boss can also talk to its workers, which are one level below the boss, not to the workers of the workers, or not to its peers. Okay, so if this worker talks to the peer, calls the peer another peer, then it's a violation of this hierarchical relationship, and it makes your programs faulty. It makes your programs really difficult to maintain, and it will be kind of a spaghetti code that we normally usually refer to. Okay, where you have a bunch of different code which cannot be understood, cannot be maintained, and it's difficult. So this is kind of a rule of thumb. If your program looks something like this, then it is a good program. If it looks like this one is called by this one is called by this one, then it is very, very messy, and you should be rethinking of redesigning your method in your program. So this is one kind of key hint that you should be doing. Okay, the static keyword is can be applied in Java. It can be applied not only to methods but also to the fields. Okay, to instance, the variables of the class. So what does the static mean? The static means that you can basically execute that particular method without instantiating the class itself. So it is literally called the class method, right? So so in order to declare a class method, you should go and use the static keyword, and it's pretty simple. So one good example of these static methods could be the math class. Math class is just sort of a package, and inside this package you have a lot of different methods that you can use without instantiating this math object. So you don't need any state in this particular math. These functions are sort of pure functions, right? So again, what could be the criteria for deciding whether you want this static method to be static or not? One particular criteria is that it is not dependent on a particular state, right? So this is it doesn't depend on certain side effects, if you might call it, right? So it is this particular method is sort of a pure method. It just takes the input, and it's not dependent on any other thing. It just takes the input, does something with the input, right? Something meaningful, and then returns the output. And it basically gets all of its context, okay, from the input that you provided into the method. So if this method exists, like if you think that the nature of this method is like that, it is not dependent on a particular state, on a particular internal state, let's say, right? So then you can go and create it as a static method, right? And it can be shared across all different objects and classes as well. Okay, and the same applies to the static fields. Let's say you want to have a particular variable. It could be a global variable. It can be shared among multiple different modules, multiple different objects or methods. So this particular static field is maybe going to store some state of that particular program, but you have to understand that this particular field is about to be shared by multiple modules, and this is where you might be thinking about creating a static field. Okay, so for static methods, it has to be a pure function which is not dependent on some external context. It gets all of its context, all of its data from the inputs and from the arguments, and then returns the math package is a clear example of these pure functions. In order to compute a cosinus, all you need is just an angle, okay? And if you give the angle, you just can go and do the computation, okay? Or for exponent, or for floor and log, and all of these things are not dependent on any other things. So, so if you have such function in mind, you can go and create it as a static method, and you can go and bundle it inside one particular class. Okay, so yeah, so so you have to understand that like each object of a class basically maintains its own copy, every instance of a variable of the class. But there are variables which, like each of the object of a class, does not need to be to open its separate copy, right? So these are, as I said, the static fields. They just they are part of the class, and they are shared among multiple different objects. So you can also have static constants, and again, they can be accessed globally, and you just store it once. So creating a constant is pretty straightforward. Just need to go and put final in front. And the thing about final is you can assign the value for this particular final or constant only once. Okay, you cannot reassign any value to this constant throughout your application again. Okay, so or you cannot go and promote a given variable to a final. Okay, you cannot, let's say, you cannot go and define a variable and initialize it with some value, and then somewhere later in your program you cannot promote it to a constant. So it's impossible. So you have to do everything in one step. You have to declare the constant and the variable as a constant, and then assign the value immediately to that. Okay. Or basically, you can do the assignment only once, right? After declaration, and you cannot do the assignment anymore. Okay, good. So why the main is declared as static? Because Java JVM actually starts this application, and before it goes and starts, okay, it needs to know it can basically start the application without instantiating the actual objects. Okay, so again, it doesn't know which objects in fact it has to go and instantiate in this case, right? It basically goes and runs the program, and inside the program you decide which objects to instantiate and how to instantiate and how these objects interact with each other. The key idea is like in an object-oriented programming, we don't have the concept of linearity, in the sense that so there's a beginning and there is an end. And we'll talk about object-oriented. There is no such thing like linearity in object-oriented programming. It's slightly different than what we used to think as a procedure-oriented programming. It's different. It's slightly different, and therefore we have to sort of introduce certain sort of a linearity at the beginning just to boot up, okay, our program just to decide which objects to instantiate first, and then spawn the process of the program. Okay, yeah, parameters can be passed as multiple values in this one. I'm pretty sure you guys are familiar with that. So so we can go and implement, use different math functions, and yeah, and do some string concatenation. This plus does the string concatenation. Things get automatically converted into string if the operand requires a string to be there. So booleans, for example, get into true and false. Okay, or every object basically has a toString method, which can be sort of overridden, and in order to provide the string representation of that particular object. Okay, so you need to understand how to distinguish this plus, okay, from the concatenation from the addition. Like, you know that this is a left associative operator, so it starts from the left side. I mean, and it goes and does that. Okay, okay, it will convert this y into string, and the result will be this. If you want to find a sum between y plus 2, then you have to use the parentheses, and there the two operands of this plus are integers, so this will be an addition, and then this will resolve into some number, and now this is a concatenation because the one operand is a string. So depending on the type of the operands, the operation for this particular symbol changes, and you just need to understand how this works. In this case, it will result in that particular change. Okay, how you can call the methods, again, very simple, through the dot. There are three basically ways of calling the methods. If the method is defined within the class, and if the method is static, you can call it anywhere within a static method or within an instance method. Okay. If it is an instance method, then instance methods can be called only within instance methods. You cannot call an instance method inside a static method. You have to define which object's instance method you are actually calling. And in order to do so, you have to write the name of the object, and then you have to put the dot and the name of the method. So inside the static method, you can actually call this instance method, but you have to be explicit about the object that you're trying to invoke its method. Okay, the non-static methods, again, as I said, they are called instance methods, right? They belong to an object, and they normally express the behavior of an object, the way how you can go and interact with the object. So object does something useful. It can go and do some changes in its internal state, or it can do something meaningful that could be sort of the implementation of a certain functionality in your application. So these are called instance methods, and if you don't put the static keyword, it will be instance methods. Every method has to return, has to exit from this method somehow, right? So there are three basically ways of exiting the program. It's basically reaching the final block, okay, at the right brace, or just calling the return method. If it's a void, then you don't have to return a value. If it's not void, then you have to write the result, which belongs to the same output of that method. Okay, so yeah, make sure that you include the void into this one. Okay, so let's talk about the method call stack. So how Java actually deals with the methods. So in order to deal with your method calls, the Java uses a data structure called the stack data structure, and basically follows a simple algorithm which is called the last in, first out. So you can, as an analogy, you can look into this as a dishes, right? So like dishes to be washed. So you got a pile of dishes, dirty dishes, and you would like to wash them. So what you're going to do is you're going to put the dishes one on top of the other, and which dish you're going to wash first. Of course, you're going to take the latest dish. You're going to take it from the top, right? And then you remove the dishes from the top of the list, which is basically means popping. So, and that's how the methods calls are resolved as well. So how this thing actually is implemented? It's implemented into something called a method call stack. So what is a method call stack? Method call stack basically contains two things. It pushes things into stack, the two things. The first thing is the return address of that method call. So once the function finishes, where it has to come back. So it has to remember that particular position, and it has to put this into the stack. So the program will know from where it has to continue the execution of the application. And the second thing is also called the stack frame, which basically is something that contains the context or all the local variables, including the input parameters of that particular function. So whatever were the local variables, they are not lost. They are stored along with the location, the return address of that method. So all in all, you might look into this as something like this. So let me just draw it here so you have a better understanding of this whole method called stack. So it might look like a stack like this. So you can see that it has some layers in it. Okay. Yeah, sorry for my drawing. So, okay, method called stack. So what happens is, okay, so you got your app class, right? So it goes and checks your app Java file. So at the end, and so inside, let's say the app Java file, you have a main function, okay? So, and it is inside, let's say line, I don't know, 7, and let's say column 8. So let me go and check what is. Let me go and show you what is column and what is. Oh yeah. Let's keep it. So here, okay. So this is my app class, and I got the static. I got the static main method, and it has the line 4, and then you can see, okay, its column is 5, right? So this particular location tells which method of column 25, right? So it says, okay, this is the place I'm starting my application. So again, I can change the numbers here, but let's just keep it like this. Oh, sorry. Yeah. So, and inside the line 7, inside the line 7, this one we are calling, let's say, this method, right? So it's 8 and then this one, so it's line 8, this one, we're calling this method. So how it's going to do this one? So while doing so, we have some variables here, right? We got args here. Let me just uncomment that so you know what we are doing here. So we got a random object variable, and we got some other variables, some literals as well. So these are the contexts. So all of these things are stored, and the location of another method call is stored in the stack, right? So this is another method I'm trying to call. So it's going to say, so let me make the changes here. Again, just I'm using some different numbers here, but you got the idea. So it goes and stores some, let's say, variables saying x is equal to 2, y is equal to, let's say, they could be inputs, right? 1, and maybe args and some values, let's say something. Okay, so this, at this particular point, we're calling some method, and our method is, let's say, is the inside Crab's Java file, right? And inside Crab's Java file, if you can go and see some other method is being called, right? So and the location of this method is given here. So it could be another line. Could be another line. Okay, let's say it could be the line, this one, column 1, something like that. Again, the location of another method call. So this was the location of the method call called crabs.start, and now inside the crabs.start we have another method call which does a little bit of low-level job, and then while coming to that particular line 11, it went on and then it created some other context. So let's say it went on and then created a variable called, let's say, w, which is equal to 1, I, let's say, which is equal to maybe 5, I don't know, and some other variables. So all of these contexts, the stack frame, is also stored in this method called stack, and the location it left that particular code. So let's say this particular method, let's say some method which was called inside crabs.java is resolved. So now the method called stack comes and tries to continue the program from the place it left, right? It starts this one. So if in the process it goes in this one, it goes and let's say it pops it up, right? So let's say this particular method is 1111, it is resolved. So it pops it, okay? So now this particular line exits the stack. Now the Java continues the execution inside the crabs.java, and maybe inside line, let's say 18, it has another, okay, method call. So it goes and pushes that again into the stack, okay? And now starts executing the code which is inside the method call which is inside the line 18, for example, and maybe the context will be different here, okay, and so forth. So, and if this line 18 maybe is calling roll die class or something like that, roll die class. So, and this could be, I don't know, something else, and so forth. So we can go and have all the method calls, okay, pushed into the stack, and once they are resolved, we know where we have to come back, and with which context we stopped, okay, when we come back, and so we can go and continue from that particular position the execution of this code. And if we meet another method, okay, we go and push it into our stack, and start resolving that particular method. And then again, once we resolve the method, this method will go and from the method stack. And with this particular method, note that its context will also go away. So you don't know, okay, when you push this out, okay, you are losing its context. So all of the local variables defined inside that particular method will be gone. So, and this is how it's going to work. So you're going to push new method calls, and then once they are executed, they are popped from the method call stack. And every time you're calling, you're keeping track of the return address. This is the place where you have to come back when the method is resolved, and the context, okay, at which context you left this particular method caller, okay, you left this particular return address. Okay, this is the return address, and this is the context at which you left this particular address to do something else, to do some other jobs, right? And once this job is done, this goes away, and then the program gets executed as well. So once there is no method call stack remaining in your application, so it means that you kind of you're done with all your jobs, and then you're exiting the application. Okay, so this is kind of I think the simple explanation of how the methods are executed in Java. Okay, good. So we can look into the argument promotion. It's basically the same as broadening the type of the array. So the variables can be automatically, implicitly converted to some other values. For example, Boolean can be cannot be promoted to anything, right? So it is basically a true or false, right? But other types like byte can be promoted to one of these variables, and so you can see how they can be promoted. Promoting is converting them to a bigger type, okay, the greater type, where the information is not lost. And when you're passing to a function which takes double, if you pass a function like, if you pass a variable which is an integer, it will be implicitly promoted into double. But if your function receives an integer, but you're passing a double, then it won't work. I mean, it will work, but it will ask you to do some explicit conversion, because the integer is going to truncate the fractional part of the double. So you just need to understand that this kind of loss is going to happen, and you have to do these kind of things explicitly. Okay, so there are a lot of Java packages available. I just want you to look through this. And at the end, I just want you to show one particular example, a case study, where we can go and implement a game called Craps. Okay, so this game called Craps is a quite interesting game, and while doing so, we basically use some class called the secure random class, which basically generates random numbers from different distributions. Okay, and it's truly secure in the sense that they cannot be repeated. You cannot go and have the same sequence of numbers using this particular class. Okay, in a standard pseudo random number generators, they have some sort of a seed, and where you can set the seed, and then you can reproduce the same sequence of numbers. Okay, once you know the seed. Okay, for that random number generator. For the secure random generator, actually, you cannot go and reproduce it. That's why it's secure, and it gives you some sort of a truly random numbers. But this is not the point. The point is we should go and implement. Okay, you can see some examples here of rolling the dice. I will upload these examples as part of the lecture examples. I'm not going to show them because of how I have so on. Just to experiment with this particular class, you can go and run them on your time. I'll upload the code for that if you want to. But I want to show you some interesting game called Craps, and how we can go and use implement this game using simple things. So let me go and show you the flow chart. Okay, how this game is going to proceed. Okay, so this game starts with rolling the dice. So we have to kind of draw. We have to draw two random numbers, okay, between 1 and 6. That's the job, right? So we have to draw two random numbers. So we have to roll two dice. So we say roll the die. So we have to roll two dice, and basically we have to withdraw two times a random number from 1 to 6. And then we should check. Yeah, we should check. Okay, if the number is 7 or 11. And if this is true, so let me go and say yes, then we won the game. Right? Okay, but what if it's not, the sum of these two dice is not equal to 7 or 11, but instead it's equal to 2, okay? Could be equal to 3 or 12. So if the number sums up to one of these numbers, okay, then unfortunately we lose the game. So lose the game. And okay, what happens if none of these conditions work? Then we just remember whichever sum it gave. So we basically set some p, okay? So p is going to be the sum that resulted, and that's not this or that, okay? So it could be, let's say, 4, right? So 4 is p. So we set p, okay? And again, roll the die. So we roll the die. And now we have to check. We have to check if the die is, okay, if the die is equal to p. The sum of that particular die is equal to p. If it is equal to p, then we won, right? So we are the winner. Okay, but if it's not equal to p, then we check if is it equal to 7. If it's equal to 7, okay, then we lose the game. But it's equal to something else, not p, not 7, right? The sum of this roll die. Then we just simply continue the game, right? So this is how it's going to work, and this is a simple game. As you can see, we always end the game with, so let me go and indicate the end of the game by this, okay, by this ball, okay, black ball, and then this is the start of the game with something like that. So it always comes to that particular point, this program, it comes to this point. So we have this game, and we have to implement this game, and how we can go and implement this game. Now we got the idea of this particular logic of this game, right? We have to roll the dice and so forth. So I got the sample code for that. I'm not going to write it down just to save time for you to this one. So let me just quickly walk through this game, and then we're going to play this game in our code. So let me keep the changes. So I got a game of crabs here. So what I have here is I got a bunch of I got a secure random generator. As you can see, it's just a static constant. I'm just going to use one of its methods to generate numbers, and I got a method called start, right? And I'm just storing these things as constants. These values mean to me, I mean, instead of going and using this 7, 11, or this one, I'm I mean, I'm just storing them in some constants, okay, and just giving names to these things. For example, this 2 in dice look like a snake eyes, okay, and 7 or it's 11 or boxcars and so forth. So I'm just giving some names to that. And I'm also storing, talk about enumerators. Enumerators are classes the classes who know their constants, who know their objects. Normally, the class like crabs, right, doesn't know how many objects it has, right? Doesn't know its variables. You can go anyone can go and instantiate these variables. But enum is similar to class, but instead of just defining the class itself, it also defines the list of constants of, let's say, it's list of instances that it can hold. So this enum class has 3 instances, 3 constances. These are continue, won, and lost, and they can they can be used to indicate certain status of the game or state of the game at some point, right? So we can look into them later on. So we start the game again. You can look into this. We're rolling the dice. Okay, we got a roll dice method. Okay, and this roll dice method is a low-level method. So I can go and look into the kind of definition of this roll dice method. You can look into this. It's a static method. I basically go and find a number from 1 to 6. Okay, so this next int will generate me a number from 0 to 5. If I add it to 1, it will be from 1 to 6. So I get 2 dice. I'll just take the sum and I'll return the sum. And now I just roll the dice. I got the sum. I'll check the sum. If it's 7 or 11, I'm just simply saying I won the game and I'm breaking the switch. If I'm this one, it's lost. If this one, the status of the game is continue. And my point, P, is equal to this sum. Okay, and I'm just doing this continue while the game status is continue. I'm still rolling the dice. Okay, and I'm getting the sum. If the sum is equal to my point, I won. If it's equal to 7, I lost. Okay, and this will continue, okay, forever. And I mean, not forever. At some point, either I will be the one who win the game or lose the game, and so forth. And if the status is 1, I say I won the game, and the status is I lost the game. Okay, so you can look into this simple application and run this. So let me start the game. I'll say crab start, and I'll go and press run. Basically goes and plays the game on behalf of me and tells if I won the game or lost the game. Okay, it says player wins the game. So now you can see how the game actually proceeded. So I see, again, I threw the dice and it went on and it was 6, right? So 6 is neither of those winning in this one. So I have to continue. So I rolled the dice once, it was 3, it was 10, and now finally I got 6. So 6 is equal to 6. Now I won. I won the game, right? So ignore this thing, okay? Ignore that. These numbers are irrelevant right now. So I can go and replay the game again. And again, I won, right? It's kind of cool. You can go and do some, let's say, a Monte Carlo sort of experiment, okay? Trying to run this craps game for 1,000 times, or maybe 100,000 times and count. Let's go and do it, okay, for int I. I don't know how many times I win, right? So it could be, so 100,000 times I plus plus. Start doesn't tell me if I won the game, or does it tell me if I won the game? No. Okay. So let's go and make sure that basically sends okay, return true, and I forgot to wrap it with the curly brace, and now it returns. right? So I can go and let's not do it 100 times, maybe 100 times. And yeah. So, sorry, I forgot to delimit it the right way. So I can go and say grabs start count if I win the game, right? What I'll do, I'll increment, and at the end I'll print out. Okay, I'll print out how many times I won the game, right? And this will give you some good chance if it's a good game to play or not a good game to play. So out of 100, how many times you win? That's kind of interesting thing to do, right? So let's go and try that. So now you can see I got just one. I won 42 times out of 100. Let me go and start that. Again, 48. So slightly less, right? Slightly less than, like, it's not 50 to 50 game, right? So, and if someone comes and offers you to play this game, you know that it's rigged, right? You know it's not some fair game. You're like slightly less. Sorry, it's 49, but it's not even 50. So it's slightly less chance to win, right? So it's 44. So more or less, I mean, I can go and repeat this whole thing, okay, multiple times. And I can go and so 100 times, right? But I don't want to print out so many things, okay, into my screen. So let's, yeah, you know that it's like I just need to turn off all these things. I don't need to print them. But you know that this game is not a fair game. I just need to understand by just doing this simple experiment, Monte Carlo experiment, and counting the number of wins you made. Just tells you, I mean, you don't need to go and learn a lot about probability. Just go and let's run some experiment and let's see how, okay, what are the chances of winning this game for you? So it's less than 50% most of the times. Okay, good. Yeah. So let's continue with the lecture. And so the scope of the variables, the methods is pretty clear. It's within the given block or the body of the method. If there is a local variable inside a given function and there is a global variable the same name, the local variable will be hidden. The global variable will be shadowed by the local variable, and the value of the local variable will be used. So I can go and show you some example here. I think I prepared one. So this is so this goes and takes an input as an array, right? And yeah, so it's just different. Yeah. Anyway, I think I don't. This one. Yeah, this is the scope. Okay, so this. Yeah, I think it's in a different place. So this x is a global. It's a local variable to the main function, but this x is a global variable. It can be accessed by many other. It can be accessed by static methods and instance methods. So this x is shadowing this x. Okay, and inside this particular method, the value of this x will be used, not this x. And this use local variable here, a method, will use its own x. Okay, it goes and defines an x, and it goes and uses its own x. This one will use, this use field will use not this x, but this x. This particular method will use this x. This method will use its own x. and here we are printing this x. So you just need to know that, okay, which x we're using, so which one is shadowing the other one. So the local variable with the same name will shadow the global variable all the time. If you do not define a local variable, then you refer to some x here without defining it, then it will go and use the static variable, the class variables, okay, or instance variables available to you. So this is going to be sort of a global variable. Okay, good. So think the method overloading. The method overloading means that you can create functions with the same name, but a different set of parameters, right? So and the Java will know exactly, depending on the input types and their order, will know exactly which method to execute, right? So for example, this you got two square methods here, right? So you got square, which takes an integer, and square, which takes a double. And if you go and call the square with an integer literal, then this method will be used because, okay, it has two definitions. You're overloading the same method. And if you go and pass on the double, then this method will be used. So depending on what sort of data input you gave, the Java will go and select the proper implementation of that method. And that's called a method overloading. So the methods can differ based on their signature, right? And what is the signature of the method? The signature of the method is the name of the method. It's, okay, the number of arguments it can take, the type of the arguments it can take, and the order of the arguments it can take, right? So it's very important that the order is also maintained. So this means the signature of the method. You have to note that the output of the function is not part of its signature. So the methods are not distinguished by their output type. They are distinguished by their name and by their parameters. Okay, their types, their order, and their number. So this defines the signature. If this signature of the method, if the name is the same, but the signature of the method, the parameters are different, then Java can go and define them within the same class. Okay, and then can apply the right method depending on whichever input you provided to this method, right? So let's say if this method doesn't exist, like if this int method, a method that defines a square method for the integers doesn't exist, and then you pass square 7, okay, what's going to happen? Then the 7 is going to be promoted to a double, right? So you know that 7 can be promoted to a double, can be casted to double because you're not losing information here. So this method will be used, of course, but 7 will be promoted implicitly to double, and the value will be returned here. So that's what you need to bear in mind. But if you have this method, then 7 will not be promoted to double. Instead, it will be using this method because it's asking for integers. And you got a method for it which does that. Okay, let's quickly discuss about arrays, and then we can continue our topic. So arrays are basically just a group of variables that contain values of the same type, and they can contain also as well objects which are the reference types. They're not primitive like integers and booleans and other types. Okay, so arrays have a fixed size, and they can be addressed using the index, right? So indexing it can be done using this array access expression with the square brackets like this, right? So in Java, arrays start with a 0, and the highest index of the array is its length -1. So we basically know all that stuff from our previous programming classes. Okay, so how can we know about the size of the array? Using the length method. It's an instance variable. Okay, so it applies only for the instance of the array, and it's just also a constant. You cannot change the length, right? So that's how you can go and create the arrays. The declaration of the array has to be the type of the array elements, right? And then the square brackets. Inside the square brackets, shouldn't put any value, it's just a declaration, okay? And when you do the initialization or the instantiation, you have to indicate the size of the array. You can do this thing in one step or in two steps like this, right? So you can defer the initialization phase later on. So when you go and create an array, let's say if it's a numeric value array, let's say double or integer, its elements are set to 0 by default. If it's a Boolean array, its values are set to false by default. And if it's a reference type array, like a string, for example, right, or any other object class, then its value is set to null by default. Yeah, this is one thing. So we should basically, for readability, declare only one variable per declaration. Don't create multiple variables in one line because it might cause any confusions, right? So create one array in one line. So every element of a primitive type array contains the value of that particular element, right? So if it's integer, then it contains the value. But for a reference type arrays, again, the size is exactly the same, but it contains the reference to that particular object, sort of a pointer to that object. So if it's an array of string, then the array contains an address of the object where the string is actually located. And so this is something like the internal structure of the array. So we can go and create multiple different arrays, and we can iterate through the arrays using simple for loops like this, right? So it's clear. We can also do the initialization of an array using the square brace, the curly braces, right? This automatically goes and populates the array with these values, and it also sets the number of the elements in this array by default, depending on the number of that you specify here. So you can go and do this kind of initialization. Once you do this initialization, okay, so it goes and creates a new array and then assigns it to this particular variable, right? So it's comma separated keys, not necessarily integers, it could be any object, anything. It's a list. Okay, so that's the way how you can go and do this in the example. You can go and look into this. Okay, these are examples from your book. Okay, so you can also initialize the array with a constant, the size of the array with a constant, or you can just go and put some value into this. But you cannot put a variable when you're initializing an array. You cannot go and use some variable to determine the size of the array, right? So when you're initializing an array, you can either go and use some literal or some constant, which basically represent that literal or literal like this. So this is one way of dealing with the arrays. Okay, so you can make arrays as constants as well. This means that you cannot reassign anything to this array after it's been initialized, but it doesn't mean but you can go and modify its elements, right? So the array that is declared as a constant doesn't mean that you cannot modify the elements of that particular array. You can go and modify the elements of the array. You cannot reassign the entire array to a different variable if you set it to final. Okay, so we use David constants, yeah, and this is another example. Okay, so this example shows you how to kind of display the data using this, using sort of a bar chart. Okay, using the asterisks. This is kind of an example of using arrays. So you got a bunch of numbers like that represent the frequencies of like a histogram of the grades for a particular semester, let's say, and this represents from 0 to 9, and this represents from 10 to 20 or 19, and so forth. And this represents the grade that is that is 100, right? So you can know what is the frequencies of students. So you would like to visualize it using bar charts. You can do it using this arrays. The array contains the information about that, and you can simply print out as many stars as you wish. So it basically shows the histogram of the distribution of the grades for a given class. It's just an example of how to use arrays. Okay, so you can go and use arrays for calculating the frequencies. Again, this is another example. You got you got an array for counting the frequencies for the, let's say, for random numbers, for rolling the, let's say, dice, let's say, right? So, and you'd like to know how common is particular number occurring, okay? And basically increment. So you create an array with a size of 7. So you ignore the value 0 here, and then you roll the dice. So the first you roll it for, let's say, 6 million times, and then and this is the actual dice roll. So you're getting some random number, and then incrementing that particular element of the array when it basically chooses, let's say, it chooses 1, so you increment 1. If it chooses 3, you're going to increment 3, and so forth. And at the end, you're going to go and print it out and see how common the occurrence of this particular number. And as you can see, it's kind of evenly distributed, so it's kind of a fair dice. So you can go and use it for all your probability tasks and experiments, okay? If you're having probability class, if you want to. Okay, good. So you can go and use the array again for your this kind of summarizing the results, right? And then there could be some problems when it comes to accessing the array outside its bounds. For example, the size of an array is, in this case, the size of an array is 6, right? So you have different responses, and you're basically collecting the frequency for these responses. Like you would like to know how many 1s there, how many 2s, how many 5s there, and so forth. And then you got this 14 number, right? So and then this you want to know 14. So what's going to happen is, okay, so you're going to increment every time you see a particular value, but when it comes to 14, so you are trying to access the 14th element in this array, but the array size is 6, so it is going to cause an exception, and this exception is called an array index out of bounds exception. And the program will halt at that point, saying, okay, I can now go and find the element number 14. And it raises this exception. You can go and handle that exception by using this try-catch block, and then tell, okay, this particular invocation wasn't correct because the size doesn't allow you to have a value of 14 in here, okay? Because the size is 6, and you can have maximum number you can have here is 5, not 14. So just something that you need to take into account when you're working with the arrays. And it's called bound checking. Okay, so always need to go and do some bound checking, maybe through exception handling, or maybe through some if-else statements. Maybe one of those things should be in place in order to prevent this kind of problems happening in the future. Okay, so this example shows you how to use the try-catch block, but we'll talk about exceptions in detail. We'll create our own custom exceptions by the end of this first half of this semester. We'll talk about them as well. So don't worry about exceptions and what are exceptions, how are we going to create exceptions. It's just a topic of a different lecture. We'll be talking about that in a little bit detail there. So let me go and give you some nice case study, which shows how we can go and use these arrays to implement something called a card deck. So we'd like to have a card deck, and this card deck contains 52 different cards with different face and suit. Okay, and this card deck should be able to deal the cards, and it should be able to shuffle them and then deal the cards. And then once we have this card deck, we can do all sorts of experiments with different games, and then we could just calculate using, again, something called the Monte Carlo method to figure out the probabilities of different models. Okay, so it's kind of cool. You don't have to go and do all this complex mathematics in order to find out the probabilities. You basically simulate that environment, and then you have a reliable source of the random numbers, and you have this model of card games, and then you can basically build that and simulate, and then figure out what are the probabilities of certain things happening, certain events occurring in your situation. But we're not going to focus on that. We're basically going to build a simple card deck, and that card deck should be able to shuffle and deal the cards in a random order. So in order to work with the card deck, we just need another abstraction called the card, which represents an element of that card deck. Right? So card deck is a collection of cards, and then its element is a card object. And this card object has two properties. It has face and it has a suit. And it also needs to, let's say, implement a method called toString, and this has to return its kind of string representation of that particular card. So it has to say, this is, if the face is, let's say, 10 and the suit is hearts, so it has to say, okay, 10 of hearts. Or if it's like the face is Jack and the suit is a diamonds, it has to say Jack of diamonds, something like that. So this way we know which card it is, and this way we can kind of recognize the card and work with this card to implement a particular game, let's say game of poker or blackjack, whatever game you like. You can go and implement it using this particular simple notion. So this is a simple implementation of the card itself. You can see that we're basically declaring a constant, and then we are assigning a value to this constant, and note that we're assigning it once, okay? And so we declare it here and we initialize it here. So it's not happening in a single step, but it's happening inside the constructor of this card class. We'll talk about constructors later on, but the point is you can pass on some values and they are final. They cannot be changed after they are initialized. So once we do the initialization, that's done. And now we got a method called toString, which basically returns the name of this card in a format that we want. Okay, so this is a card. Now we need another card. We need another deck of cards. A class called a deck of cards, and it has to contain an array of card objects. Okay, and it has to have two methods: the shuffle method and the deal method. Shuffle method is the one which loops through all the 52 cards from, let's say, 0 to 51, and then picks some random card from the deck and then swap the places between the pair of these cards. So let's say it goes and picks the first card, and that for the first card it has to pick the pair, the couple. So it goes and picks some random card from that pair, and then it swaps the place of the first card with the randomly picked card. So and then it goes and exchange the place in between, and it does it for all the 52 cards. In this way, we will be able to do some sort of a shuffling inside a card. And dealing card is pretty simple. It's basically finding out what is the current card has been dealt. So it starts from 0 and it gets incremented. So basically return, you get the current card as an index, as an integer, and you just return the current card element in the deck to the user, okay, and then increment the current card by 1, okay, and then next time you deal the card, you just return another card, next card from the deck, and so forth. And if it reaches the end of the deck, then it has to return null because there's no more card remaining in your deck. So it's a pretty simple logic. So let me go and show you that implementation on my screen. Okay, I got this deck of card. I got a card here, and it's basically the same as I showed here. And I got a deck of cards, right? And this deck of cards, is implemented in a form that I explained. So we got an array called a deck. It's an array of cards, as you can see, and there's an integer which represents the current card that is going to be dealt. And it's not dealt yet, but it's going to be dealt when the deal card method is invoked. And we got just some constant which represents the number of cards we have in the deck, and the random number generator. It could be a secure number generator. You decide that. Okay, and these are just some strings. Okay, we have like the faces, and then we got the suits for the card: hearts, diamonds, clubs, and spades. And then we just create this. Okay, the array, initialize this array, the deck. Current card is equal to 0, and then we have to go and create new card and then assign each element of this, each new element of this deck with a particular value. So what we're going to do is again say count is equal to, so it starts from 0, right? So a new card, and it takes, you remember, it takes two inputs as the face and the suit, so it goes and passes on the face. So it is a remainder, so it means that it is going to, let's say the count is, if the count is 0, then this will be returned. Okay, if the count is, let's say 13, the 12, then this will be returned, right? So, and then if it's 13 again, it comes back to ace, and again, so it repeats this particular cycle 4 times. If you, let's say, take the remainder by 13, right? So it's when the count is equal to 51, so it will be king, right? But if the count is equal to 51, you divide it by 13, it will be 3. So it's an integer division. So this will evaluate to 3. This will evaluate to, okay, 51. This will evaluate to 12. So this is 12. This is 3. So the 12th element is here. And I mean, the 13th element is here. Its index is 12. And the 4th element is here. So the final card will be King of Spades, right? So King of Spades. So this is how we're basically assigning the values to the card. We're using some little bit of a mathematical trick to do this job, okay? So to assign these values. So now the cards are ordered, okay? The first, it starts from the Ace of Hearts and it ends with the King of Spades, right? So that's how we're gonna initialize the card. The next thing we're gonna do is we have to be able to shuffle this card. Again, shuffling the card means it's going and it's setting the current card to 0 because we shuffled the card. The card has to be dealt again from the top, and then we start picking the card from the first card, okay, until the next cards. And for that first card, we have to find a second card. And this second card could be any number, okay, any number. So any card in the deck. And what we need to do is we just need to swap their places, okay. So we take the first card, put it into the place of a second card, and the second card should be placed into the place of the first card. And we just repeat this whole process for all the cards, and that's how we do this simple shuffle operation. And dealing card is simple, right? So it's just check if the current card is less than the length of the deck, and if it's that, then it goes and pulls the current card from the deck. It basically returns, let's say if it's equal to 0, it goes and returns the 0th card and then increments it to 1 and so forth. It goes and keeps dealing the card like that. So let's go and use this thing in our in our example. So let me go and create a deck of cards here, okay? And I can go and iterate through each card like this, right? So what I can do is I can, deal the card from each card. So what I'll do is I'll print out that card. So when I deal 4 cards, I'll break the line and then start from the new line and so forth, just to save the space. So let me go and start that and see what kind of card shuffling I can get. And this is what I got. So I got Queen of Diamond, and I got 3 of Clubs, and then 4 of Hearts, and then 3 of Diamonds, and so forth. You can see that it's kind of random, right? That doesn't have any particular order in it. And I have a way to deal these cards in this order. And now I can go and, let's say, implement a particular rule for this certain rule for this game, and then see how the game progresses if I go and run this game over and over again with these randomly shuffled cards. Again, this is just something for you to try it on if you want to play and to experiment different strategies, different games, and see who has better chances of winning when you're playing a blackjack or when you're playing a poker or something. Okay, good. So you can go and check. You can go and iterate through every element inside the deck, by doing something like that. But that's not a good thing, in this case, because we already have a method called deal card. So we should be using this deal card method, this one, because here we're just kind of accessing the internal structure of that deck card. So I'll just simply remove this one. I don't really need that here. This one is better. Okay, good. So let's go back into our idea of arrays. So this is basically the implementation. You also have another exception that might happen. This exception happens when you try to let's say, access the instance variable or instance method of an object which hasn't been initialized yet. So let's say you got this deck of cards class, right? And it has a shuffle method. What if this particular what if this my deck of cards hasn't been initialized yet? Yes, it is declared. You know that this particular variable exists and it's been declared, but it doesn't have a value. Its value is equal to null, right? And then you go and try to call for the null, you try to call the shuffle method. In this case, you are going to have null pointer exception. This null pointer exception says that there is nothing to refer to. There is no object to which I have to refer to in order to execute this particular method or in order to access that particular value, right? There's another way of dealing with for loops. This is called you can call it an enhanced for statement. But the point here is that you can iterate to every element of the array. So this element of the array, this is the array, and this statement that you would like to do with the array. It makes it readable, kind of, that your loop is now readable. You can call it as a for each if you want to. So this for each is something that iterates to every element. But there is one limitation to that, right? So the limitation is you cannot modify the element. You cannot modify this parameter element inside the body of the for loop. You cannot reassign some value to that. That is the limitation. It's only a read-only structure, so you can only read the values from that particular array. But if you want to modify it, you have to use the traditional counter-controlled for statement. So again, and in a counter-controlled for statement, you have at least the index, which you can kind of keep track of. So this is one thing that you would do. Of course, we'll be dealing with other different types of for, especially when we talk about streams and lambda expressions that have been introduced into Java since the standard edition number 8. So we'll be talking about those things, about collections, the lambda expressions, later on in this semester. So some students were saying, okay, I miss Python because I learned Python, and Python has a lot of interesting things like functional programming things where I can go and use some lambda expressions and work with collections. Well, Java has that one as well, and we'll be talking about those things as well, so don't worry, and those things are there, and they have the for each method where you could actually deal with these elements in a slightly different way, like in a function-oriented way, of which we'll be talking in later lectures. Okay, when you pass the array to a method, you need to understand that the arrays are a reference type, and it would be kind of a waste of space if you would copy all that stuff into another memory as a local variable to the method. So when you pass the array to the method, instead of going and passing the values to the method, it basically passes the pointer to the method. So whenever you go and make a change inside the array, the change is affected globally. So that particular array's values are going to change. So you have to understand that these arrays are reference types, and whenever they are being passed to methods, they are passed as reference types, not as copies. So when you pass the modify array, and then this modify array takes an array as an input, right? So this modify array. So, and then you go and let's say modify a particular element of the array. The array's element will be modified to multiply each array. So each element of the array will be multiplied by 2. So it will be affected. It will be affected. This will indeed change this array. So you can go and test this particular case here. So, and it will be changed. But if you go and pass the element of the array into this function, and then you go and modify that element, this element will be, because it's an integer and it's a primitive type, the method will only accept the copy of this element, the value of this element, right? So, and then when you go and make changes into the value and then exit the function, all your changes will be, discarded. Those changes will not be moved to the array itself. So you're not passing the reference here, right? So, and this one will not be changed, So you can see this output here, right? So the effects of the passing reference of the entire array. So initially the values were like this, you passed it to the array, now they've been multiplied by 2, and then you can see the values have been changed, and that makes sense to you. Okay, but what about when you're passing the element of the array to a method? Okay, when you passed it, it was 8, and then you multiplied it and it became 16, but once you exited the function and then printed this particular thing again, somewhere here, okay, it was 8 still. It wasn't changed because you're passing a value, not a reference type, not a reference object. Okay, so this is called call by value, call by reference. I just explained that to you in the example of arrays. So it's not just for arrays, it's for all reference types. Okay, so any reference type like objects, okay, they can be, they are passed like they are as a reference. Okay, there's another example case study of a great book which allows you to compute the maximum statistics, the basic statistics about the grades. I'm not going to show you that example, but it's given in your book, and I'm going to upload it into our lecture examples case, so you can go and try that example. It shows you how to iterate through different arrays and play this one. So it's a grades books example. It's a kind of helpful example. You can go walk through the code yourself and see how to work with the arrays. Okay, so we can also work with the two-dimensional arrays or any n by n dimensional arrays. If it's a two-dimensional array, then it's just a matrix. So you have to first define the row and then the column, and it looks like this. So every row is basically an independent set of arrays. So you can go and look into this like this. So you got an array of arrays, right? So you can it's not like it looks like a table, but what it really is just an array of arrays, right? So if you look into this, like, so you got, this is the zeroth element of the array, but, okay, the 0th, okay, row is in fact an array itself, right? So it has 4 elements, and the row 1 is an array itself, and row 2 is an array itself. So what we have is array, okay, this whole array of arrays. Right, so we can continue this idea and have multi-dimensional arrays like this. So you can go and initialize the arrays using the simple array initializer like this. So it's a two-dimensional array. So it has 2 rows. Okay, this is the row. This is the 0th row, the first row, and these are the columns. Okay, the first column, sorry, 0th column, the first column, and so forth. So this is how you can go and declare the array and initialize the array. And as I said, every element of this two-dimensional array is an array itself, and its length is not like a table, right? So it means like, okay, the first element, first row can have 2 elements, the second row can have 3 elements. So it's possible to declare arrays like this. So if you want to don't initialize the array, you can go and initialize it in this way, where this means the number of rows and this means the number of columns. But if you have, like, for each column you have different length of arrays, then you can go and you can partially initialize it like this, and then for each element, for each row, you can initialize another array, okay, on your own. So it's just a two-dimensional array, and you can basically, you need a nested for loop to traverse through all the elements of this array, right? So you can have 2 loops, okay, one for the rows and one for the columns. So you can go and read each element in this two-dimensional. If it's a 3-dimensional array, then you would probably need a 3, okay, nested loops to go through every element. Okay, so it's very important to understand these kind of multi-dimensional arrays, because they're massively used in solving different algorithmic problems, especially the problems of a dynamic programming, where you would like to store different states of your program, okay, in different cells, and you should just understand how to traverse through the cells of your array in order to kind of approach to the solution of the problem. So it's very, very important that you understand how to properly traverse the array in the right direction, and how to properly cache your intermediate solutions into the array. So this way you approach to the problem and then you kind of save your computational resources by caching the certain intermediate values from being recalculated again. So this is one thing, and you can look into in another example using the grades book. This one does the grade book for multiple different exams. Okay, this one, that one, the first one was just for one exam. This one does it for multiple different exams. So there's one course and then multiple different exams, and you can go and do some simple logic for outputting the charts. So that will be kind of your the scores for the first student. So he had 3 exams, and these are the 3 assignments, and these are the scores he got for 3 assignments, and so forth. So every row represents a student, every column represents the grade for a particular assignment, and you can go and use this thing, and it basically generates some sort of a report on what you did. Okay, so it's pretty straightforward implementation. You can go and look into this and how to this one. Your labs basically have all that information given to you. I mean, you're basically doing some practical exercise on that as well. So you can also create variable length argument lists. These basically take inputs as arguments, as arrays. For example, you have a function called average, and then once instead of using this square brackets, if you put this ellipsis, this means that this particular function can take arbitrary number of arguments. So, and these arguments will be packed into an array called numbers. Okay, so you can iterate through the numbers and then find out the elements. So remember that these 3 dots, this ellipsis symbol, okay, represents multiple variable length arguments, and this means that your function can have arbitrary number of arguments. So you can have 2 arguments, 3 arguments, 4 arguments, and then all of your all of these variables will be packed into one single array of double type, right? So one thing that you need to note about variable length arguments, they always need to appear at the end of your arguments list. For example, you have some other argument, let's say some integer or some string that used to be that you can pass on to this average before you go and execute this one. So let me go and show you one thing here. I think I'm prepared some example here. Yeah, so here is just an example of an average. You can go and pass some other arguments in front of it, but this one has always need to be at the end, of course, right? It makes sense. You cannot make it like this because you don't know the length. You don't know the length of this particular argument, right? So that's a compilation error. You can see it's highlighting that. So make sure that it's always at the end of this variable length arguments are always at the end of your arguments list, and it basically represents as an array, right? So you can go and look into this example here just for more things. Okay, cool. So I think you can also read the values from the command line. You remember that you have main, you have this main, inside the main function you got an arguments is a string, and this args is basically an array, right? You can check what are the arguments and how you can pass these arguments. These are just delimited by a space. So if it's equal to 3, you're basically saying something. So what you're doing is you're basically creating a simple Java application which initializes some array. It takes 3 inputs. If you're not providing 3 inputs, then it's kind of raising an error, saying that, okay, it's not what I'm expecting for. So, and now if it's equal to 3, then the first argument is the array length, the second one is the initial value, and the third one is the increment. Okay, you're parsing them because these are string, right? This is string. You're parsing them into integers, basically explicitly converting them into an integer, right? This is how you can do this, okay? Explicitly convert them into an integer, parse them into integer, and then you're basically printing, you're populating the array with the real values, and then you're printing them out. So, for example, if you go and once you compile this particular source code into a class file, into bytecode, and then you go and say Java init array, it will raise this error. It says, okay, you haven't provided any arguments. But if you go into your console and say Java init array and then pass on all your arguments, and note that your arguments are delimited with a space character. So if you go and put these arguments, it's going to print out the array that you were looking for. And it's basically doing something useful, right? You can take some arguments, directly from the command line and then use that to do something meaningful in your application. They're providing some input into your program directly from the command line. Okay, so you also have the wrapper class. I mean the class, the package class, which called arrays, which contains a bunch of useful methods to work with arrays. For example, you would like to populate your all the elements in your array with particular value. You can use the fill method. You would like to search for a particular value inside the array. You're going to use binary search method. Sort is going to sort out the array in an ascending order by default, right? So you can go and pass on the static methods and the arrays, and they will return, okay. They will change the array in place to a new array. Okay, so for example, the sort is not returning anything. It makes changes, okay, inside the array. So it goes and sorts the array. Okay, it makes an kind of rearranges the elements in your array in such a way they are sorted. So it does it inside the array. It doesn't return anything, right? So same thing goes with the fill method. So when you say fill, it simply fills the array with the values like 7 and so forth. So it happens inside the array. It doesn't return any particular value. It happens inside. So these are the kind of useful methods. You can also use the array copy method to, let's say, copy the array into a new array, because you know that arrays are passed by reference. Let's say you just need a copy of this array because later on you'd like to modify this array, but you don't want to modify that array. You just want to keep it for your later use. How are you going to do this? Okay, make sure that the length of this array and this array is exactly the same, and you can just provide a bunch of arguments, okay, from where you would like to start to copy this, okay, original array, so from the 0 index, okay, and in the new array, from where you'd like to start to populate it, okay, from the 0 index, until which part you'd like to start populating it. So I'm populating it till the end. So basically what it does is it copies the entire content of this array into this array. And now these are two different arrays. They are stored in two different places in the memory. So if you go and modify this particular array, it won't affect this array, okay? Because now you can go and do some changes, independent changes between these two things without, okay, worrying about other things. It could be useful. You can use a binary search and so forth. Okay, the parallel sort method also exists. It does quicker sort in a computer which has multi-core CPU. Like perhaps you know the merge sort, right? It's kind of something that can be parallelized, okay, into multiple different cores. So it takes advantage of this parallel sort, okay, merge sort algorithm, and just does it in a way faster speed, okay, for large arrays. Okay, so you can go and use that one as well. We can also create a different object called an array list, and this array list is cool because it has a dynamic size. You can append elements to the array. You can remove the elements from this array list, and we'll talk about this. Just a part of a collections package in Java. We'll talk about collections in detail in later on. But for now, if you need a dynamic list, okay, if you need some list, not an array list, where you'd like to change, you can add and remove the elements from the list easily without redefining the array, new arrays, and recreating all these things. Okay, you can go and use this array list, and it has this diamond notation. Again, it's a generic. We'll talk about that later on, which basically tells, okay, for now you can look into this as saying, okay, I can go and define an array. An array list has to be a type of this, so it belongs to the type of this. It's an object itself, but this object can work with some different types. And then you can say, I want this object to work with a particular type, let's say an integer or a string or something else. So, and it has some methods, add, clear, contains, all of that. These are kind of quite easy to understand what they do, right? So let's see some examples. So you can initialize this object. So what basically you're doing is you're declaring an array of string. Okay, and you can add different elements. You can add, if you pass one argument, it basically appends it to the end of the list. If you put 0, then it puts it to the top of the list, right? So, and then you got get method, which basically gets the ith element of the list. and then you can also remove this particular element, or you can remove the first element from the list, and so forth. You can address by the type or by the index. You can remove things like this. So it's kind of useful thing to work with. And in fact, if you need the concept of a list, you can use the array list like this for now. And we'll talk about this lists and collections in detail when we talk about, again, about this lambda expressions and different ways of dealing with the collection in a functional or programming way. It's a slightly different way of dealing with things. But right now, it's just, say, some sort of an implementation of, let's say, a list in your array-based implementation of a list in your Java programming, in your Java standard API. So this diamond notation, okay, once you do the declaration during the initialization, you don't have to do this. You can just skip this part, because once you do this like this, it will create a new object called array list, and this object is the one which represents a collection for a collection of strings. So you don't have to rewrite the same thing again and again. So I think that's it. Hope that these two concepts that we discussed today were familiar to you, but I hope that you learned something new as well, and at least you now have a good understanding of how those things are used in Java. So hopefully we'll do some practice in the RIS sessions, and we'll cement our understanding on that in these fields with more of challenging tasks and problems. Thank you very much for your attention.